Looks like we're live. Hello everyone and welcome to yet another recreational programming session. Let's make a little bit of announcement and start the stream. How about that? Red circle to indicate that we're live. Then I'm gonna say live on Twitch. And what are we doing today on Twitch? Today we're continuing making programming language. That's precisely what we're doing. So I'm gonna give the link to the Twitch channel, twitch.tv/Tsoding, and I'm gonna ping everyone who's interested in being pinged, and the stream has officially started. Hello everyone. So the programming language that we're developing is called Porth. It's a concatenative programming language for computers, right? You can find the source code in the description, right? If you're watching on YouTube, or if you're watching live, you can find the source code here in the chat. You just need to, issue the ! project command, and you get the source code. Hello everyone, welcome. So the compiler is actually pretty cool. It's at pretty cool state. It is self-hosted. It is written in itself. And the reason why it's it's possible to rewrite it in itself is because it's native compiled language, right? So it basically compiles into the x86-64 assembly. So there's a couple of things missing. So today we're not going to do anything super special. Today we're going to try to implement negative numbers for our language. Believe it or not, our language does not support negative numbers. We implemented a lot of different things in this language, right? There's a lot of examples in here, including games and even web servers, right? So there's like a website. We wrote a simple website in this language, and this language does not support negative numbers. It doesn't. So you don't need negative numbers for any of those things, which is quite surprising. So, and it's worth implementing your own programming language to just not really discover that, but to actually understand that, right? So that you don't really need negative numbers for a lot of things. I'm not saying that you don't need negative numbers at all, but for a lot of things, you don't really need them. So far, we needed them to interact with the operating system. Linux kernel actually indicates errors by returning negative, return codes from the syscalls, right? So that's what it does, and that's why you need sort of like a signed comparison, but you don't really need negative numbers for that. You just only need signed comparison. And the only time you need negative numbers is when you developing like something gameish, where you have coordinates and positions and stuff like that. And because of that, you kind of need negative numbers because your position can be like in the negative side of the coordinates or something like that. So anyway, implementing negative numbers is not that hard. So I decided to like go ahead and implement that. So should be pretty straightforward. Thank you so much, Peanut Butter, for a one tier one sub for 2 months. I don't know why I said it like that, but yeah. So essentially, let's take a look. So if I create a simple program, right? Foo.porth, maybe not for, but negative.porth. And I'm going to include the standard library just in case, even though I don't really need it right now, but I'm going to include it anyway. And I'm going to print 34, 35 plus, right? And let us see what's going to happen. So I'm going to try to compile this entire program, and I'm also going to run it simultaneously. It is going to print 69 because 69 is a sum of 34 and 35. If I try to put minus in front of this number literal, I think it's not going to compile. It will say unknown word minus 34, right? It's because it tried to parse that word as a number. It couldn't parse that word as a number, so it thought that it's some sort of a word, right? And then, since such word is not defined, like it couldn't resolve that word. What's funny is that you can kind of define that word by literally like defining a constant for that, and I think you can even do something like this, right? So there is a subtract operation in our language, and you can subtract from 0, right? And you will kind of get a negative number, but it's negative in 2's complement. So this is sort of like a magic of 2's complement. Negative number is not really that different from underflowed unsigned number. So it's unsigned, it's like whether it's signed or unsigned is determined by the operations that you apply to it, right? So 2's complement makes no difference between adding signed and unsigned numbers and subtracting signed and unsigned numbers. So you can kind of do like that, and I think it will even work if I try to like swap them around. I will say 35 minus 34, and I will sum them up, and I think the result is going to be 1. Even though our language doesn't support negative numbers, I think this will work, right? So let me try to do that, and yeah, it worked, right? There you go. So we don't have an explicit support for negative numbers, but because of how x86-64 CPUs work, it kind of worked out anyway. You see what I'm talking about? It kind of worked out anyway. So, but that doesn't mean that we don't have to implement that. We still have to implement that. So that's actually pretty funny, I think. Are the comparison operators signed? Yes, they are. The arithmetic is not. Whether it's kind of interesting thing to say whether arithmetic is signed or not. If we're talking about addition and subtraction, it doesn't matter whether it's signed or not signed, because addition and subtractions work for both signed and unsigned because of 2's complement. That's the beauty of 2's complement. So if you never heard about 2's complement, like I really recommend to read about it. 2's complement. Right. So, but if we're talking about multiplication and division, in case of multiplication and division, you have to distinguish between them. Right. So, and because of that, we do have separate operations for signed division and unsigned division. I think we don't have a separate multiplication for signed numbers because we never really needed that, but anyway. So, I'm going to put the link to the 2's complement Wikipedia article in the description for anyone who's interested. So 2's complement. Oh, and furthermore, like I think the best explanation of what 2's complement is was done by Ben Eater. Like I really recommend to check out Ben Eater's video about 2's complement on YouTube. So just a second, Ben Eater, 2's complement, right? Yeah, this one. It's actually very cool. I really recommend to check it out. So it is that one, and also I'm going to put that in the description as well. So 2's complement negative numbers in binary, right, by Ben Eater. There we go. So cool. So the way we actually parse negative numbers in compiler, we're using the standard library. In the standard library, we have a function called try_parse_int. And you, as a user of the Perl programming language, can use this function. It's a pretty convenient function. It accepts a string and returns you an integer and a boolean, indicating that it succeeded to parse something or didn't succeed to parse something. So we can even test it out how it works. So let me see negative. So for instance, you have 35, right? And you say, I want to parse it, right? Try parse int. And since it returns 2 values and the boolean that indicates the success is the last one, you can literally just do if, and that automatically consumes the boolean returned by this thing, and there you go. So here you have 2 branches where you succeeded, success, and this is the failure, right? So the stack-based languages make it super easy to return 2 values from a function and like indicating whether you succeed something or not. And now in both of the branches on the stack, you have the parsed value. In case of a success, you have the value that you just can print. In case of a failure, you just have you have a like undefined value, right? If the result here is going to be false, int is kind of undefined. So what you have to do effectively is just like drop it, right? Because it can be anything, and then say that I couldn't parse that specific number, right? So I can say error could not parse as number, right? So this is going to be eputs, and if I try to run this entire thing, it says 35, right? So it managed to parse it as a number, But if I put minus in here, it will say error could not parse as a number. So you see? So we have a special function that you as the user of the language can use, and compiler also uses the same function as you, right? So if we add support for negative numbers to this specific function, not only it will be available for everyone, it will be available for the compiler as well. Right, so this is how it works. The compiler is sort of the main user of its own library, right? And here's an interesting thing. So recently to the library, we added like a simple support for sockets. That means that soon we'll be able to implement the language server built into the compiler. That's actually a pretty cool idea. I should do that. Where's my pencil? Just a second. Yeah, just let me write it down. Here's the pencil. Yeah, because we already have the technology. I think it is already kind of possible to like have a language server like built into the compiler. Essentially, just make it so when you run it with a special subcommand, it starts to listen to the like socket of a language server, and then you can write an extension for Emacs or for. I think you already have extensions, right? So you only need the server. LSP for Porth. We already have the technology. Alright, so that's pretty POG, isn't it? Okay, so let's go ahead and implement that. I think somebody subscribed, I00 Alan, thank you so much for 4 months of Twitch Prime subscription. Thank you. Alright, so let's go ahead and do that. So I think I'm gonna go to here and let's see how it works. Okay, so here we're checking whether the string is 0 or not, right? Whether it's 0 or not. Another interesting thing that we probably need to do, right, is just check the first minus, the first dash. So let's do something like this. So I'm gonna sort of peek into this entire thing, and so I know that n, right? I know that n is greater than 0, right? So that means I can just take s and take a look at the first character in here, and if it is equal to minus, right? So that will push a boolean onto the stack. Right, but that will kind of break all of the rest of the code, because the rest of the code expects the string to be on top. So what we can do in here, in fact, I think we can do let and actually put the result of this comparison behind the string. So none of the code below kind of breaks. And here, like somewhere here, we have the indication that the entire thing is unsigned. And in here, we can add additional thing, saying something like minus, right? And we return the result, right? We return the result, and if the minus is set, right? If minus is set, we have to multiply it by a negative number, right? We have to negate it. So I'm thinking, what's the easiest way to negate it? Since we know it's a 2's complement, we can essentially just do not and then 1 plus. There we go. So just 1 plus. And that's it. Actually, believe it or not, that is it. Almost. I think the other thing we have to do, we have to sort of skip the negative value, right? I think we have to skip the negative value. We have to subtract the size and add this thing like that. So that should work. And yeah. So for those who doesn't know, in 2's complement, to actually negate the value, what you have to do, you have to invert the bits of the value and add 1. So that's essentially how you do that, right? So that's essentially how you do that. Alright, so let me try to recompile that, and as you can see, it printed something, which is rather interesting. Right, so This is because our print intrinsic, the intrinsic that we're using here, isn't capable of printing negative numbers. In fact, we don't really have anything that is capable of printing negative numbers. So I wonder if we can do something like, so I have put u, which by the definition, right, you see in the name, it has u indicating that it doesn't sign, so it's also not going to print anything. Right, so to check that it actually did everything correctly, we have two options right now. We can basically go to C, assign it to unsigned number, and sort of reinterpret it as a signed one and print it. And another one would be to implement something like put I, which supports negative numbers. I think I'm going to do the first one thing first, the C route first, just to check everything, and then we're going to implement something like put I. So I'm going to go into the main.c, right, so this is going to be something like stdio. And the easiest way to do all of that, so since it's a 64-bit number, right, we have to be aware of that. uint64, so this is that. And then maybe I need to include stdint.h. And what I have to do now, right, so I think I have to do LLD. I have to take a pointer to this thing, reinterpret that pointer as the pointer to a signed number, and dereference it like so. So basically it takes the bit representation of this number and reinterprets it as a signed one and prints it. So that way we can see whether it's like the actual value it claims to be. Right, so, and here we're supposed to have -35, right? So let's go ahead and compile this entire thing, main.c, and I'm gonna run the entire stuff. And what does it print? It prints -35. So C confirmed that it is in fact -35. So, and it's kind of strange that it's so large that it's unsigned. So I suppose you have to do something like maybe ULL, so the compiler is not complaining, and yeah, there we go. So that's pretty cool. So we successfully parsed the negative numbers, though from within the language we cannot confirm that because we don't have any routines that are capable of printing such negative numbers. Does anyone have any questions of what we just done? So we got some subs, Stians0, I hope I pronounced your nickname correctly. Thank you so much for tier 1 subscription. Thank you, thank you, thank you. Thank you. Gia, hello, welcome. Your mom is so large that she's inside. Got him. Why is it so complicated to do negatives? It is not complicated. So what you just have to do, you have to just Google something called Node.js, right? So you just Google this thing and you download it, right? Preferably LTS because it's like a long time support. You install it, right? And you just run it like this, right? So you just run it like this, and there you go, -35. It is easy. You don't have to do that, right? So, yeah, it's very easy. Thank you so much, Xiaonan, for tier 1 subscription. I hope you pronounced your name correctly. Thank you, and welcome back to our epic Port Club. So, for anyone who's wondering why working with negative numbers is so boo-hoo hard, for those people, I'm gonna put the link to the Node.js in the description. All right. So, for people who are afraid of negative numbers, there we go. Use this language. This is language for you. There we go. Okay, so this is a to's complement. This is another thing. So let's go ahead and implement something like put u. So foo negative dot porth. std.porth, where is put u? So here is a put u, and another thing we need to implement. Oh yeah, so if put u does not print negative numbers. So what I meant is probably that I want you to have separate function that implements fput_i, but this to do is very, very old. So, but that's fine, I suppose. That is totally fine. So what we do in here is essentially while this entire thing is not equal to 0. Okay, so that makes sense. All right. So we also pre-allocate some sort of a buffer and some other stuff. Okay, so I think I'll be able to implement that super quick. Okay, so this is a proc fput_i, and I accept an integer, and then I accept the file descriptor into which I'm going to be sort of printing this entire thing. This is a number. Interestingly enough, we quite often use a temporary buffer. Maybe it would be nice to actually get rid of things like put_u and put_i and implement a thing that basically converts an integer into a string by using temporary buffer, and then implement all of these things in terms of the temporary buffers. So that would be actually interesting to do. I think that would be actually super interesting to do. But not right now. Not right now, a little bit later. Where did I go? Okay, so this is basically going to be the end. So, okay. What do we have to do in here? So I suppose I might just like assign this entire thing to something like, right? So this can be fd, like so. And if number equal to 0, I just straight up print 0, right? So it's gonna be 0 fd fputs. Next thing, we may want to do the following thing. If this stuff is less than 0, right? If it's less than 0, I might as well actually just keep this thing as a condition in here. So that kind of pushes the boolean, indicating that it's 0 or not. Though this one is complicated because if it's less than 0, I wanna kind of negate it, right? So I'm gonna do duplicate, and if it is sort of negative, the thing I'm gonna do is basically negate it like that. So I want to do sort of like not. But this is not what I want, actually. This is not what I want. So, because I want to have like a series of transformation on the number, if you know what I mean. I want to have a series of transformations, but it doesn't really allow me to do that. So, let me see. So I wanna, I guess, just do over in here, right? So I don't bind the number and the rest of the thing to anything. And then here I can do fd like so, right? So then later I can just work with this entire stuff slightly different, right? I just don't want to waste any of the names in here, right? So, and I kind of want to do number fd, right? So this is a number fd, and number less than 0, right? And if it is less than 0, right, I do number not 1 plus, right? So I sort of negate it, right? So this is the new number, and then I put fd back. So essentially now on the stack I have the indication whether it's negative or not, right? So I can have something like negative, then the number itself, but the positive one, right? So the positive one, and then the fd itself, which means that I can use fput_u to actually print it. Oh, okay, so that's actually pretty cool. So I didn't really have to do anything, but I need fput_u to be available somewhere here. There we go. So that's actually pretty cool. So that means here I have negative, Negative number fd, right? And if it is negative, right? If it is negative, I'm gonna essentially print minus fd fputs. I'm printing a minus. Then I'm printing the number of itself, fd fput u, and that is basically it. I think that is literally it. Okay, which means since we're using fput u already takes into account the zero case, right? It already takes into account the zero case, so that means I can just do it like that. I can simplify the entire thing if I'm reusing fput u, right? So that becomes way simpler. And maybe now I can actually merge these two branches, right? Maybe I can merge these two branches, I'm not sure. Maybe I can actually. Yeah, you know what? I think I can, because I can do it like that, right? So this is the situation now, right? If it's less than that, then so, and then I can just return that number as so, number not 1 plus, right? But otherwise, I can just return it as it is. So then later, I can do fd fput u, and then that is it. That is it. I effectively merged these two things. So here's the number fd. If it's less than 0, that means I print minus, right? Then negate that number and then print it. And if it's not, you know, negative, that means I just like let it fall through and then use that one. Okay, so through this sort of like analysis and synthesis, I came up with this design of this function, right? So this is basically a demonstration of how I designed the code, if that makes any sense, right? I don't try to write the code perfect the first time. I usually iterate on the code several times until I discover, like, until I gather all of the necessary information and come up with a simple design that actually reuses some of the existing code. So that's how I usually develop, and I think that's a pretty good way to develop things, right? So it's sort of like constantly having like a dialogue with yourself and trying to come up with a simpler and simpler design. Right. To be fair, I don't really know how people expect to write code perfect the first time. To be fair, if somebody's writing very simple code perfect the first time, that means they actually wrote that multiple times in the past, right? So they're just reusing some of the designs from their head. So yeah. Anyway, so let's see if this entire thing compiles. Maybe it doesn't compile. Okay, so this is a C code, but let's try to do that. All right, so our example does not use fput I, right? So maybe we have to do something like fput I, but since we don't have put I situation, we'll have to use something like std out in here. And let me see, and that worked. Look at that. So it prints minus 35. So that's pretty cool. And then if I just do 35, it will not print. It prints 35. Nice one. Very cool. Okay, so I wonder what exactly is going on. So I think I know what exactly is going on. So in the try, so we already found a bug, try parse int. We only have to do this if this condition is true, right? So I completely forgot about that. So dupe if, right? So something like that. There we go. So only have to do that if that is true. So data stack does not have enough something. Otherwise we have to do n and s. N and s. Okay, so at least for now it's gonna be like that. Okay, so this is a 35, and then we go to the negative, put minus in here, minus 35. There we go. So we have a negative numbers. How about that? So we have some subs. Nate, Lift 151. Thank you so much for 4 months of tier 3 subscription. That's actually a very generous subscription. Thank you. Yo, says Nate. Yo to you too. And also we have I'm a Robot with tier 1 subscription for 28 months. For 28 months. Thank you so much for 28 months. The message is 28 month Кас. Мне нравится его безумная идея. Thank you so much. All right. Alrighty. Type checking save the day. Yeah, that's exactly the reason why I spend so much time like on the type checking, because of these situations like that. The type checking in this language is not perfect, and in fact, it is very difficult to make static type checking perfect in a concatenative language. But it still catches a lot of errors. And it's actually pretty cool. So, by the way, I found a fundamental problem with concatenative languages that I have no idea how to resolve. I have no idea how to resolve that problem, and I'm not even sure if I'll be able to ever resolve that problem. But this is precisely the reason why I wanted to implement this language, just to discover things like that. Essentially, I'm an active user of something that I called compiler-assisted refactoring, meaning that if I want to refactor something in the source code, I just modify the signature of the function or the definition of the structure, like once, the target, the target's signature and the target definition, and then I compile the entire thing and go to the compilation errors, fix the compilation errors, and that way I refactor the code. So it's a compiler-assisted refactoring. So it is kind of difficult to do that with concatenative language, and I'm gonna tell you why. So imagine that you have two functions, foo and bar. Right, and you have a following expression. So foo, let's say foo accepts three arguments, a, b, and c. And then you have a function bar, which accepts two arguments, right? So since foo accepts three arguments, let's actually like do something like this, right? So bar accepts two arguments, foo accepts three arguments. So in case of a regular expression-based language, if I were to refactor this function to accept more arguments, that would fail saying, bruh, you apply two arguments to bar, but bar expects three. In concatenative language, how would you write this kind of expression in concatenative language? Well, first comes D, right? Then comes bar, but you would define bar something like C, B, bar, right? So this is basically the second argument of foo, then A, and then foo, right? So you see what's going on in here. So this is basically this expression, but written in reverse Polish notation foo port. So if after that I refactor bar to accept three arguments, how will it be parsed? It will be parsed like this. So, and now the compiler will not complain about bar, it will complain about foo. So here's the thing, you modified bar, but compiler complains about completely different function, which makes the car kinda difficult. Not impossible because the compiler still complains, but kinda difficult because the compiler starts to complain about irrelevant things. So you see what I'm talking about? Like, it's something fundamental and I have no idea how to resolve that. And if D happens to be like compatible type with bar, it gets even more complicated. So, and I would never even think about that if I were not to implement this language. I only discovered this problem because I tried to implement this language and I programmed in that language long enough. So, that is very interesting. It might be possible to resolve this by augmenting this syntax so it's not purely concatenative. Yeah, you can solve that by making language not concatenative, which kind of hints that maybe it's a fundamental problem, right? But to be fair, it's not that big of a problem. I wouldn't say it's a showstopper because I still managed to implement the whole compiler using this language. It's not like a, very big problem. It's just like a minor annoyance. Yeah, you see what I'm trying to say. Okay. What means to be concatenative? Function application by default. So, all right. So that's what we've got. So I suppose what's interesting is that since we already have try parse int, right, so the compiler should already support this kind of stuff. And And we yet again have in the case of self-perpetuating feature, right? So, yeah. Just thinking. Okay. I wonder if I have tests for try parse integer. So I do have tests. Oh, okay, there we go. So I even have the test for that. That is very, very cool. So I might try to enable this entire thing and just remove that. So I can take the previous version of the compiler, so porth, and just do tests try parse int.porth, and I have to actually do com -r, so com -r, and it will say that successfully parsed this one. Oh, okay. Put u, we need to have put I. We don't have put I because we only have fput I. Let me find put u. So here fput u. Put x, we'll need to implement put x at some point. Put I int stdout fput I. Okay, so successfully parsed this one, which is strange. Oh, I see. Yeah, so that's fine. That's totally fine. That is totally fine. So we need some sort of example for negative numbers. Some sort of example. Maybe I'm going to just go ahead and do 35 minus 34, and I'm gonna sum them up, and I'm gonna use something like put I, and then the new line in here. Right. So let me try to do porth, compile, run, negative.porth, unknown word. Oh, okay. So yeah, first thing I need to do, I need to recompile the whole compiler. That's pretty cool. Compilation took 1 second. Holy shit. I wonder why. Maybe because I'm actually streaming. The result exclamation compile time must be a single number, and what it's talking about. Oh, okay. So I see what's going on. So essentially it's a bug that we introduced. So just minus is recognized as 0, I think. I think it is recognized as 0 right now. Try parse integer. Right, try parse integer. So I can actually add this thing in here, right? If we're getting into the business of like negative numbers, we have to test all of these things in here. And let me see. Right, so this is going to be Bootstrap porth. Let's run it. So this is going to be tests try parse integer.porth. There we go. And as you can see, just a minus was recognized as a number, first of all, and it was parsed as 0, which is the bug that we have to fix. So let's go ahead and fix that. All right, try parse int. And how we're going to be doing all of that? So this one is very interesting. It basically means that we have to do like a second check, the second check for whether it's empty or not after we parse this entire stuff, which is kind of annoying, not gonna lie, but it feels like this is something that we have to do, right? At least for now. Maybe we can simplify that in the future, but I don't really see how we can simplify that in the future. So essentially, right, so it is greater than 0, only then we're trying to do something in here. Otherwise, so this is just like that. So we have to do this, this. Right, I'm dropping all of that, and I just need to return 0 and false. Right, there we go. So it's kind of a hack, but it is what it is. But now it says minus is not a number, right? So as you can see, empty string is not a number. All of these things are numbers. This thing is not a number. Negative number is a number, but just minus is not a number, and that's quite important because minus is an intrinsic for subtracting numbers. So otherwise we won't be able to do that. All right, so let me recompile the compiler now. Right, so the compiler should be able to do all of that. Okay. So, and then I'm going to try to recompile the compiler with itself, new version of the compiler, and see if it's capable of doing that. It seems to be capable of doing that, which is nice, right? So I can recompile the compiler several times now, right? That is very, very cool. So with a new version of the compiler, let's actually try to test, like, you know, all of the tests, just to see if we didn't break anything, right? So yeah, we have a lot of tests, and yeah, it's quite important to run them from time to time, just to make sure that we didn't break anything. Does anyone have any questions? Is -0 even meaningful to have? Maybe, I don't know. Does it cause any problems? Does it cause any problems? That's the question. Shit. Okay. So this thing fails because we modified it, right? If I just try to run it, so this is what expected, and this is now the output. The current behavior is correct, so I'm gonna just say, however the program behaves right now is correct. So this is the new output, right? So if you take a look at the modified output, here it is. So let's try to test that one more time. Does anyone have any questions? Is porth white space sensitive? What is that supposed to mean? I have no idea what that means. All right. So far so good. I didn't think we failed any tests. All right, so everything seems to be okay. So let me create a separate branch, negative numbers. Right. So here are negative numbers. I didn't think we need any of that stuff, and maybe none of that stuff. Make try parse int parse negative numbers. Right, so that's what we implemented. I'm going to push that branch right into the description. Right into what? What did they just say? I'm an idiot. I'm sorry. I'm just trying to talk and read the chat and think about the next thing I need to do simultaneously. All right. So I think I remember that I started to like actually mark things where I would like to have negative numbers as negative. But that's a very interesting thing. So the problem is Bootstrap compiler right now does not support negative numbers, right? So if I try to run porth run tests and what was that? Try parse integer porth, it will work. But if I use Bootstrap compiler, so the previous version of the compiler, that I think it will not work. But oh, it still works. Okay, that's fine. So because I keep thinking that try parse int tests the compiler, but in reality it doesn't test the compiler. Okay, it doesn't test the compiler, so we'll probably have to have a separate test for the compiler. But in any case, first thing I want to do, I want to update the Bootstrap. Right. So maybe I'm going to do something like this. Porth run test.porth update Bootstrap. So I basically have a special script that basically updates the Bootstrap compiler. All right. So it just recompiles the current compiler and then just uses that. And then we're going to say update Bootstrap. It will take some time because the amount of changes is actually quite huge. So as you can see, it's like 100,000, almost 100,000 of changes within the FASM file, right? So what I have to do, update Bootstrap. Okay. And we're going to push that right into the repo. So porth now supports negative numbers, but we don't really test that, right? We don't really test that. I suppose what I want to do is I want to create the following thing, negative porth. Right, did I ever create negative? No, I didn't. So we're going to include the std port, right? So here is std port, proc main in 35 minus 34 plus put I. I remember I did that. Didn't I not move that? Yeah, I think I forgot to move that to the test folder. So this is going to be puts. Okay. So and then I can do something like test pi that output tests negative dot port. There we go. So if I take a look at some of this stuff. Oh, okay, I just realized that I haven't updated my branch for quite some time already. I haven't updated my branch for quite some time already, so I'll have to do that right now. Okay. Alright. So we'll quickly do that. Because there's a lot of changes. Yeah. Merge origin master. Luckily, did I already push the negative number? Yeah, I already updated the Bootstrap and all of that stuff. I wonder if it's gonna break if I try to rebase this branch on top of the master, because there's like updates on this entire thing. Maybe it will not break. Let's see. Let's see how good Git at resolving the merge conflicts. So I'm gonna rebase it on. I'm gonna just do it like that. Rebase it on top of the master. So it's rebasing. So it failed to do that. I see. Okay. Alright, so it definitely failed to do that. So that's not that big of a problem. I can basically abort the rebase. Right, let me try to abort the rebase. And since it's like, it's not a master branch, so I can just reset minus hard head minus 1. So basically remove the update of the Bootstrap. Git reset minus hard head minus 1. So yeah, there we go. And maybe I'm gonna just force push into that branch. I'm not force pushing into the master. I'm just force pushing into my separate branch, and then I should be able to quite easily rebase it onto the master. There we go. So that is rebased more or less. Okay. Yeah. So I want to update the stuff one more time. Let's update the Bootstrap. Yeah, there we go. Update Bootstrap. Right, I'm gonna push that. We updated the Bootstrap. I don't know why, because I need to force push that one more time, I suppose. Is that what I need to do? Probably, yeah. So let me take a look, and that didn't print. That printed 1, so let me go to negative.port, and I actually want to do something like this, because I want to see -1, right? Test, let me go here, test pi, update negative, right? So here's the negative, and revert the buffer, so this is -1. Okay, so that's cool, and let me run all of the tests now, just to make sure that everything's fine. The compiler... Did I remove Nasm? Yes, I removed Nasm very long time ago. Very, very long time ago. Does anyone have any other questions? Okay, so everything seems to be fine, which is nice. All right. Add tests for negative numbers support in the single test in the compiler, right? So we're gonna do this thing. Cool. So now I want to go through all of the places where I mentioned negative numbers, right? So for example, in Game of Life, yeah, there we go. So for instance, in a game of life, we have a game of life thingy. So let me actually see, do I have to do something like this? No. So it's gonna be port. And I'm gonna run example game of life. There we go. And we have a very simple game of life example, right? And what's important for game of life is being able to count how many alive neighbors you have, right? So that's a primary operation. So, and the way I do that is I basically iterate the square 3 by 3 with the center at the current cell. Right, and essentially what I'm doing, I have like a two-dimensional like nested loop which iterates from -1 to 1 in the outer loop and from -1 to 1 in the inner loop. Right, so in that way I'm iterating 3 by 3 square, right, and I'm using these values as basically, you know, deltas from the center, right. So, and since I couldn't use -1s, I had to do 0, 1, minus, which is not particularly great, right. So essentially what I can do now, I can just replace it with -1, right. So in here I'm just iterating from -1 to until 1, and that actually works correctly. Should work correctly. Let's see. I'm going to try to recompile, and as you can see, it works. As you can see, it works. Let me now remove that. So this is 1 negative. So fput does not print negative numbers, so I already fixed that. Okay. Use negative numbers in game of life example, right? So we would do that. Negative. Where is another negative? So this is lame. Oh yeah, I remember this one. So essentially we're supposed to be using the constant at fdcwd. So it's basically a POSIX constant which is equal to -100. Though it is unclear. Is -100 equal... Oh. Maybe it doesn't matter, right? Yeah, it doesn't matter. With the 2's complement, I was thinking that if it's 32-bit negative, like -100, it could be different than 64-bit, but if you truncate that stuff, it doesn't really matter. So essentially, for some reason, this thing didn't work. Right, I do have a constant in here. Right, I do have a constant, and it was defined like that. And I suppose now I can define it like this. And that shouldn't cause any problems, but even that shouldn't cause any problems, I don't know. So that was kind of weird. So this should work now. This is basically for generating assembly. So if this thing breaks for whatever reason, I think the entire compiler will break as well. Yeah, 2's complement is amazing. Like, the more I learn about 2's complement, the more I'm amazed by, like, how perfect it is. Like, who came up with it? It's just insane. Like, it just, like, fits perfectly into what we're trying to achieve. Best invention in the history of computers. Kind of similar level of invention, probably UTF-8, right? It kind of has like similar in like amazing design that is somehow backward compatible with ASCII. 2's complement feels kind of like that. It feels kind of like UTF-8. Anyway, so let me also actually find every time we're using at CWD. So this is that. This is just a couple of examples. So here it worked. I don't understand why it didn't work in that place. That's weird. Maybe I'm being silly, as usual. So this one is fine. This one also fine. All of these examples work. I think I'm just an idiot. Oh yeah. Oh yeah, that's true. So this is another place where I would like to just do that. And at fdcwd. So yeah, cool. So this is changes in port and also in the standard library. So because of that, we may want to do something like Bootstrap port. and recompile the compiler with itself. Okay, unsupported word. Okay, so this is because my Bootstrap compiler does not support negative numbers yet, even though it should, right? Because we recently updated the Bootstrap compiler. It's just like I didn't bootstrap it yet again. So let me quickly do that. I'm bootstrapping my compiler. Okay, so, all right, cool. So that works. And now I'm gonna just recompile it with itself. The compiler should be able to recompile itself several times, so I keep recompiling the compiler with itself. And let's run the tests to ensure that I didn't break anything. Right. But UTF-8 isn't as amazing. Okay, I guess it's subjective, sure. Does mod OP work with negative numbers like mod? Which ones specifically? You mean... It's a really strange question. If you want to have a mod that works with negative numbers in Porth specifically, you have to use emod, which is not particularly an intrinsic. And in fact, it doesn't really matter whether it's intrinsic or not. So it's just like, currently it is implemented like that, but it doesn't really matter. So if you need like mod that works with negative numbers, here's the word that you need in Porth. And it doesn't really matter what it does and how it is implemented. That's the word you need. Right now it's a function, right now it's an inline procedure. Tomorrow it might be an intrinsic. Who knows? We don't know. That's the power of abstraction. It doesn't matter. How often do you update the Bootstrap compiler? Every time the behavior of the compiler changes. Even insignificantly. Okay. Okay. So everything seems to be fine. Let's find the rest of the negative numbers. Okay, fputu does not print negative numbers. In fact, it shouldn't. It shouldn't. Okay, so this is not needed anymore. Well, honestly, okay, so it's not really about negative numbers anymore. It's about negation of the numbers. It's about negation. And I'm thinking maybe we just need to have a word that negates a number. I'll need to think about it. Because we can already do that, right? So we already kind of have a word, right, which accepts an integer. Well, we don't really have that word. I have that word in my head, which essentially, you know, inverts the bits and adds 1, right? Oh, by the way, people quite often ask me, why, since I have things like let and pick, right? Since I have things like let and pick, why don't I merge proc with let and pick so you can just like have values in here, right? Or something like that. I don't know what exactly people mean, but I expect that what they mean. If I do that, if I by default merge proc and let, I won't be able to write this kind of code. Because it is a concatenative language. Application function applications by default. So as you can see here, quite often, in fact, you just don't want to bind anything to any name, and you just want to describe the function as a series of applications without mentioning any variables names or anything like that. So that's why procedures by default don't bind anything, right? It's sort of like an opt-in, right? So you explicitly opt in to having some arguments in here, and if you don't care about that, you just like do a series of function applications. Yeah, it's kind of like a point-free, you know, programming by default. So yeah, and maybe in the future, if we have type inference, you won't need to write something like this, right? So I don't know. So that's why. So this is a negation, and then I can do something like All right, so this is negative, duplicate negative, and then equal. And I'm not sure if it's that useful, right? I'm not sure if it's that useful, but I can keep it. I can keep it just in case. So I invert the bits, and then I add 1. So that's basically negation equals component. All right, so do we have any other mentioning? So yeah, this one is done, negative. When we support negative numbers, okay, so that's also should be that. Negative, print in tracing does not support negative numbers. Oh yeah, that's very interesting, okay. I'm not really sure if print should support negative numbers. Yeah, I'm gonna leave it as it is now. Right. Okay, cool. So let me recompile the compiler, just to make sure that nothing is broken. I'm gonna do that a couple of times. Oh, really? And by the way, having negative numbers explicitly may speed up the compilation, because now you don't have to waste sort of operations to get negative numbers. You can just like at compile time make them negative, right? Which should be the thing by default in the first place, but I mean, yeah. Okay, let's actually test the compiler and make sure that we didn't break anything. So here's an interesting thing. We need to test the compiler every time we modify even standard library, because standard library is part of the compiler. Compiler is the user of the standard library. Modifying the behavior of the standard library modifies the behavior of the compiler. So even if I add something to the standard library, I also have to retest the compiler and rebootstrap it. So that's very important. That is very, very important. Does it make sense? Hopefully that makes sense. Okay. Use negative numbers across the compiler where appropriate. Right, there we go. So, and we already tested everything, so that means I'm gonna just update the Bootstrap. Is this test-driven development? No. Okay. Update Bootstrap. And I'm gonna push that right into the repo. I'm not sure, do I want to push it? I guess I can push it, because like I'm about to merge this branch into the master, so I didn't really have to push anything, but yeah. Let's merge the negative numbers now. And there we go. So now the compiler officially supports negative numbers, and the negative number support is in the master branch. I wonder, did we mention negative numbers in the README? I think we have like a very simple rudimentary language manual. And here, yeah, there we go. Currently an integer is a sequence of decimal digits, which is already not true. Right. Okay. So only unsigned integers are supported right now. Okay, cool. So currently integer is a sequence of decimal digits that optionally starts with a dash to indicate a negative integer. When an integer is encountered, it is pushed onto the data stack for processing by the relevant operations. Okay, currently an integer is a sequence of decimal digits that optionally starts with a dash, maybe in parentheses, to indicate a negative integer. Okay. Okay, so let's update README. Let's update README and let's push that right into the repo. So I suppose the negative numbers have been officially implemented. How about that? Does anyone have any questions? TDD is simply over obsessing over unimportant thing in testing. That's what it is. Don't waste your time, please. Okay, so we got some subs. Let me acknowledge them. Thank you so much, JF Vaz, for 8 months of Twitch Prime subscription. Thank you, and welcome back to our podcast. Unary plus one. Unary. Is that how I say it? Unary? Probably never. I didn't see any point in it. All right, so no more questions, and I guess let's make a small break, and after the break continue working on other aspects of the compiler.